Hello, my name is Darwin Chang, and today I'll be showing you how to run the workflows that we have provided on DNANexus. So let's imagine a scenario where we just got our data back from IHG, sequencing data, FASTQ files for donor 28, left shoulder 7. We just sequenced the UCSF 500 for this sample and for the donor 28 bulk. So in order to kind of understand where you're at, let's go over each workflow really quickly. The bulk workflows are for the donor bulk samples. These will be our normals for mutect. We also need to use the RNA workflow, which is for our RNA sequencing data. And we also need to use the single cell workflows, which we will use last using the DNA data. So the first step we need to do is process our bulk sample, depending on whether you have UCSF 500, which uses a specific target interval list, which is a subset of a sort of the exome capture list that we have. So these are different. We use NimbleGen currently, but for exome, because the capture is different, we have to use the CCAP exome interval list. So that's why these workflows are different. Make sure that you select the correct one before running your workflow. So for example, let's just say we recently got the FASTQs for donor 28 bulk. We want to go to the workflow folder and select bulk UCSF 500 workflow. Click that. Select the top left input for FASTQs. And then we need to go to the donor FASTQ folder where they were downloaded and or moved, and select all the FASTQs. We then need to go to workflow actions on the top right, set output folder, and select the same folder where those files are that you just used are. So we'll then run this, although for the sample I already have. So here I will show you the output. What we want from this is the coverage, alignment, HS, and insert metrics, as well as the realign.recalibrated BAM and its index file. We also want the Pindel-Indel VCF, as well as the duplication metrics. Sometimes we want target coverages if there's poor targeting. And then we want the input variance for phasing and MPileUp informative SNP input files. So all in all, this will be 12 files that you will download, and download it as a text file, and use wget option -I to download a list onto our server using the text file that you downloaded from this bulk URL. We then want to run the RNA workflow. The RNA needs to be done before the DNA because we use the RNA BAM that is processed for MPileUp. So we use RNA Workflow version 3. Here it's a little specific, but what we need to do is select reads 1 for the first input and reads 2 for the second input. So imagine that we just got donor 28, left shoulder 7 RNA. We just got these 4 files. So for the first input, we need to select read 1. And for the second, we need to select reads 2. So the second and the fourth, or the even numbers, basically. You can see by R1, R2, those are the reads. Lane doesn't matter for RNA. We then need to set the output folder to, again, where our input files were, and then just run. So you'll do this for your entire batch, and once that is finished, you will then run the single cell workflow for UCSF 500. Again, you do need to wait for both the bulk and the samples RNA workflow to finish. So after, we need to set our output folder for the DNA UCSF 500 sample. If this were an exome, there would be an exome folder instead. But in this case, we're using UCSF 500. So we select the DNA folder. We then go to the DNA folder and select all the FASTQs. Similarly to the bulk, it's not like the RNA where we split the reads, just put it all in one. We then go all the way down to the bottom and select the patient bulk BAM. Again, this is the realign.recal BAM. So we just go to donor 28, select this BAM, and then down here we need to select the sample's RNA BAM. And you'll use it here. It's the sorted deduplicated star genome, and it will usually start with the sample name. So donor 28, left shoulder 7. We then need to take the bulk Pindel Indel VCF. That's this one right here. As well as the MPileUp informative SNP input and the variance for phasing input. Right here. And right here. That's all the inputs. Just make sure that, again, you're specific. These need to be the correct files for not just the FASTQs, but they need to have their matching bulk, RNA, bulk Pindel Indel, and the bulk MPileUp informative SNPs. So what I like to do at the very end is just check my output folder to make sure that all the files were correct. And then you click run. And let's just say that, you aren't exactly sure if you use the correct files. You can select the workflow and monitor. And let's say that we're not sure if we use the right bulk. Here we are, it's the correct bulk. If we aren't sure if we use the right input, you can simply right click and show the file, and it will show the path, donor 28, so that's the correct one. Same thing for input variance for phasing, it's the correct file. And since we've already done this, I will terminate this, but obviously you'll let it continue. And then when we need to download our files at the end for the DNA, we need to download the coverage. This is actually for footprints. So it shows the number of base pairs with a certain amount of coverage. I believe we set ours to 5 reads total per base pair. So this kind of shows like the quality of our sequencing. We then select the alignment HS insert metrics. Again, at the very beginning, it's very similar to the data that we get from the bulk sample. We then download the recalibrated BAM, the freebase.vcf, and the Pindel Indel VCF and the duplication metrics. These are all the same when compared to the bulk. The two files that are different are the input variance for phasing and the mpileup informative snip for the bulk. And for the DNA, we need to download this funcatator, text, and mutectfilt.vcf. These are these files are produced in our single cell workflow at the mutect2 step. We then also need to download the indel master mutation lists, which is just a list of filtered indels, as well as the normal master mutation lists. And these are optional downloads, but it's more just to make sure that our inputs or that our files were correct and there's nothing wrong with any transfer of data when using R scripts within the master mutation list creation app. But let's just download these for safety. We can always look at these inputs later. We then also need to download the LOH files, and these are for our loss of heterozygosity plotting. Output is for UV. And then we also need to download these sorted filtered BAMs, which are from haplotyping. We also need to download the pindelfilter.vcf, which we will use in IGV to manually inspect our indels that we annotated in the indelmml.xlsx file. In total, it should be 29 files. But again, you don't have to download all of these. For example, if you wanted to make a shorter list, you would just simply download these ones. But the LOH one is necessary, as well as these and the BAMs. For RNA, it's quite easy now. All we need to do is click the star genome.bam. Again, it's very simple. You'll just select the D28 LSR07 sorted deduplicated star genome BAM that we used in our UCSF 500 workflow for single cells. And then after, you will go to the bottom. Again, this is all sorted by name, so you'll get the insert metrics as well as the duplication metrics and the genes.results and isoform.results files. Again, the way that you'll do it is you'll get the bulk URLs and download as a text file, and then use wget with the I option on our server. So that's it. That's how you'll run these workflows. Generally, this will take a while, so it's best to, make sure that we get our money's worth and do this correctly. So again, make sure you double check your files. It's very easy to lose track of where exactly you were, what sample you were doing. You might miss a sample. So it's best to be as cautious as possible. Thank you so much for watching. Hope this was informative, and have a good day.